Welcome back to Math 103. This is video number 10 on measuring power. Last time we were looking at a weighted voting system defined not by quota and weights, not by numerical quota and weights explicitly, but rather by a certain verbal description. Right? So this was a simplified version of the UN Security Council in which there were 4 players, that is, 4 member nations, W, X, Y, and Z. On the one hand, each council member has 1 vote, and a majority of votes is required in order to pass a resolution, right? So as of then, it seems like, okay, we understand how to do this, but now we're given an extra piece of information, that W and X each have veto power, right? So each one individually has veto power. That's what veto power means. It's power that a single player has to block any motion by voting no. Okay. So the task was to list winning coalitions and find the critical players in each, and the caution was, do not attempt to express this in terms of numerical quota and weights, although it turns out there is a way to do that. It's not the obvious way. Instead, just find all the winning coalitions based on this pair of criteria for passing a resolution. To put it briefly, in order to pass a resolution, a winning coalition must contain both W and X, and it has to have at least 3 members. Right? That's the way to acknowledge all the conditions that were imposed in the verbal description of this weighted voting system. Right? W has veto power. That means that W must be in every winning coalition. X has veto power. Therefore, X must also be in every winning coalition. Furthermore, it takes a majority, that is to say, at least 3 out of the 4 members voting yes in order to pass anything. Right? So this is now our neat verbal description of what any winning coalition looks like. Having written down that description, it's not hard to list the winning coalitions. Certainly there's the Grand Coalition. You've also got W, X, and Y, but not Z. Right? That too is a winning coalition. It has at least 3 members, and it contains both W and X. We also have W, X, and Z. Similarly, contains W, it contains X, and it has at least 3 members, and that's it. There are no other winning coalitions. There's no other way to write down a set of members of the council, a set of players, containing W and containing X, and having at least 3 members, which is to say 1 or 2 additional members besides W and X. Right? These are the only ways to accomplish that. Having a complete list of winning coalitions means that now we can find all the critical players, again, without referring to any numerical quota or weights. So W is in every winning coalition, and therefore has veto power, and is therefore always critical whenever it appears. So there is no passing a motion, there's no passing a resolution on this council without W voting yes. So W is critical wherever it appears. Similarly, X is critical in the Grand Coalition. It has veto power, and it is critical everywhere it appears. Right? There is no winning coalition without X. How about Y in the Grand Coalition? No, Y, if we cover up Y here and just look at the remaining members, W, X, and Z, they do form a winning coalition. So if everyone else is going to vote yes here, and Y decides to switch sides and vote no, the resolution still passes. So Y is not critical here. Similarly, Z is not critical here. In this winning coalition, notice that there are no 2-member winning coalitions. So in a 3-member winning coalition, every player is critical. Right? If Y were to drop out here, that would leave just W and X, and W and X, just the 2 of them, do not appear on our list of winning coalitions. Now that we've reasoned out which are the winning coalitions and which are the critical players, now we can find the Banzhaf power index of each player just by counting. So we count up and find that there are a total of 8 instances of criticality overall, so everyone's fraction of the power is going to be out of 8. And then W possesses 3 of those instances, X possesses 3, Y possesses 1, Z possesses 1. Right? So it's sometimes helpful to think of this in percent terms. W and X each possess 37.5% of all the actual power. Y and Z each possess only 12.5% of the actual power. Until we completed this analysis, we didn't have a good way of answering this question. We were told something about how each member of the council has 1 vote, and that's all very nice, except that some votes count differently than others. W and X's votes count differently from Y and Z's votes, because W and X have veto power. That extra piece of information had to be accounted for somehow, but until we really did this analysis, we didn't have a way of coming up with these concrete numbers. There are no dictators in this system. No one is a one-member winning coalition. We are told in advance that W and X have veto power. It might not be obvious until we do the analysis, though, whether Y and Z are dummies, and the answer is no, they are not, because each one has some power. Okay? We note that there are instances, each one has an instance of being a critical player in a winning coalition. And according to this conception of power, according to Banzhaf's conception of measuring power, Y and Z do have some power, therefore they are not dummies. We can also answer the question, how many times more powerful is a player with veto power than a player without veto power? Well, since W is a player with veto power, and has 3 instances of being critical, whereas Y and Z are each players without veto power, and they each have only 1 instance of being critical. So a veto power player has 3 units of power for every 1 unit possessed by a non-veto power player. So the answer is 3. What we've just done is quite significant. Even without any given numerical information about quota and weights, we have gained a new insight. A player who has veto power in this system is 3 times more powerful than a player who does not have veto power. You are very unlikely to have come up with that precise number just by staring at the verbal description. But we were able to reason it out without any information about numerical weights. Now, it's messier to apply this same analysis to the actual UN Security Council. The actual UN Security Council has 15 members. 5 of them, the permanent members, have veto power. And it actually requires 9 yes votes, not a simple majority, but 9 yes votes in order to pass a resolution. Now, we could carry out very much the same analysis as what we just did, and it requires a bit of work, but it can be shown that a nation with veto power has approximately 10 times more actual power on the UN Security Council than a nation without veto power. Let's sum up what we've done on Banzhaf power distributions. We started out talking about proportional voting schemes. The idea there was to assign weights in proportion to population. A country that has 4 times the population would have 4 times greater weights in the system of weights. Okay? Or that could be in proportion to the number of popular votes received. So in a parliamentary system, a party that receives 4 times as many votes as another party would receive 4 times greater weight in the parliamentary system. And the idea there was that that would give the larger party exactly 4 times more actual power. Well, we saw that it didn't actually work out that way, typically. What actually happens is that there's a different distribution of actual power than what was intended. So computing the Banzhaf power distribution sheds light on that discrepancy between the way you thought you were distributing power and the way you're actually distributing power when you set up the system. Right? So this analysis reveals which players are being shortchanged. In particular, when you have a dummy in the system, that's someone who's being severely shortchanged. A dummy might be the representative of some small district that's entitled to some representation, but in the dynamics of coalition formation, it turns out that that representative has no power whatsoever, no actual power, in spite of having weight 1 or weight 2 or whatever it is in the formal system. We also looked at weighted voting systems defined by a complete list of winning coalitions. So this is without any numerical information about quota and weights. In spite of that, we can find the critical players in each winning coalition. And once you've done that, then you can answer all the remaining questions you'd like to answer about dictators, veto power players, dummies, and the power distribution itself. So the key is, once you've got that complete list of winning coalitions, you can proceed to do everything else. Finally, there were weighted voting systems defined by some kind of a verbal description, and the key example there is the UN Security Council, right? Whether it's the actual UN Security Council or a simplified model of it. Here too, the first task, is to determine the complete list of winning coalitions. Once you've got that complete list of winning coalitions, it all proceeds from there. Find critical players, and so forth. For the sake of giving just one concluding example, let's consider a university committee consisting of the president, dean, English professor, mathematics professor, and student representative, and we will denote them P, D, E, M, S, respectively. This system, the way this committee works, we're not even told a number of votes that the president casts. We're not even told a number of votes that the English professor casts, etc. All we're told is that in order for a proposal to pass, it must have yes votes from one of these collections of committee members. So if everyone votes yes, great, the motion passes. If everyone except the English professor votes yes, then the proposal passes. If everyone thinks it's a good idea, but the math professor is saying no, it passes. Right? If just the president, dean, and English professor want to pass this proposal, and the student representative and math professor are against, it passes. Okay? So this is a complete list of all the subsets of the committee, all the collections of committee members who, if they vote yes, can pass a resolution. Here are the questions. Find the Banzhaf power distribution. Determine all dictators, veto power players, and dummies. And finally, how many times more powerful is the president than the student representative? So you are invited to work on this as a concluding exercise. I'm going to pause here. The solution is on the next page, on the next slide. Reasoning exactly as we did before. Given the list of winning coalitions, and knowing that it is a complete list, we can go through and determine who's critical in each winning coalition. For example, we see that the president is critical in the Grand Coalition, because if we covered up that P and look at who's left, DEMS, so that's everyone else, well, that collection of everyone else does not appear anywhere as a winning coalition unto itself. Therefore, the president is indeed critical in the Grand Coalition, and right away you know that the president has veto power. And sure enough, you could have seen that another way. You could have noticed that the president appears in every winning coalition. It was probably the president's idea to set up the system this way. It's good to be the king. So after carrying out this analysis and finding critical players and counting up, there are 19 instances of someone being critical, and sure enough, this is how the power is actually distributed. And it would have been very difficult just to stare at a verbal description or at a list of winning coalitions and dream up these numbers. We really had to carefully go through and figure out who's critical. At the end of the day, we discover that the president has 7 instances of being critical. That is to say, the president is critical in 7 winning coalitions. The student representative is critical in only 1. Therefore, 7 over 1 equals 7. The president is 7 times more powerful, according to Banzhaf's analysis.